The chapter on air masses must go on to comprise four components. First, what are air masses? What are their characteristics and how do they originate? That's the first part. What are air masses? What are their characteristics and how do they originate? Second is associated with the classification of air masses. The observation led to the construction of weather maps showing the surface distribution of weather elements such as temperature, pressure, winds, and precipitation. The concept of an air mass. What is an air mass? An air mass is defined as an extensive portion of atmosphere whose physical properties, especially temperature, moisture content, and lapse rate, are homogeneous horizontally and vertically for hundreds of kilometers. Thus, an air mass has two basic characteristics. One, vertical temperature distribution, that is lapse rate, which is a measure of warmth or coldness which affects its stability. Second is the homogeneous moisture content, which is an indication of the latent heat. Higher the amount of moisture content in general, higher will be the propensity of the air mass to hold energy. As the air mass extends through many latitudes and covers hundreds and thousands of millions of square kilometers, the horizontal homogeneity is far from achieved, and small differences in the physical properties such as temperature and humidity exist from one point to another at the same level. The nature and degree of uniformity of an air mass is determined by the nature of the source area. So, if they go on to originate over a continental region, then they will be continental in origin. If they go on to originate over a maritime region, they will be maritime in origin. So, an air mass will fundamentally have two broad characteristics: homogeneous temperature condition, homogeneous moisture condition, and a vertical lapse rate. These air masses, as they go on to move from their place, they go on to bring about certain type of a change in themselves as well as change in the atmospheric properties. And if they go on to be resting in the place, that will be determined by the age of the air mass. So the older the air mass, the more intense the characteristics are. That brings us on to the origin of the air mass. Thus, the most notable centers for the development of air masses happen to be semi-permanent high-pressure areas at the outer limits of the Hadley cell. That means subtropical high-pressure belts. These are going to be one of those regions. That is a semi-permanent high-pressure areas. That's one. Then thermally induced high-pressure regions. Thermally induced, that is one that is induced by temperature. So that if the air goes on to sink, it goes on to subside. Thermally induced high pressure region over the poleward continental margins. That means near to about a tundra region, taiga region, where the air mass is going to sink and subside. Low pressure zones are not suitable for the origin of the air masses as they accentuate unevenness of temperature by bringing air of different temperature and moisture characteristics. So the first is the surface, the second is light divergent winds, and the third is the age. With regard to the latitudinal position, there can be 5 types of air masses. Arctic and fringing land, the air masses that originate over Arctic and fringing land, they are symbolized as A. Those that originate over Antarctic and around Antarctic region, that is symbolized as AA. Those that are towards the polar regions, that are symbolized as P. That is the continents and oceans around 50 to 60 degree north and south, there is polar regions, they are symbolized as P. Continents and oceans around 20 to 30 degree north and south is symbolized as called as tropical and symbolized as T. And oceans close to equator are equatorial air masses and they are symbolized as E. That is with respect to latitudinal position. With respect to the underlying surface, 2 additional types are imposed on the preceding type. One is the source of origin. If the source of origin is going to be oceans, it is called as maritime and this symbolizes M. And if it is going to be continents, it is going to be called as continental air mass and symbolized as C. Now these air masses can be identified on the basis of their symbol, their properties, their temperature, and their specific humidity. So, if there is continental, Arctic and Antarctic air mass, that will be symbolized as a Ca, Caa. The continental polar air masses are, that is Cp. The maritime polar air masses obviously will go on to be moist because of their property of being maritime. The continental tropical air masses, that is Ct, are warm and dry air masses. Maritime tropical air masses, in contrast to continental tropical air masses, are going to be warm and moist. Maritime equatorial air masses, Me, that we're going to be calling it, they're warm and very moist. The second way in which the air masses can be classified is on the basis of the type of modifications that they undergo. As the air masses move away from their source region, they are affected by different heat and moisture exchanges with the ground surface and by dynamic processes in the atmosphere. There are two mechanisms by which the air mass can be modified. One is thermodynamic modification and the other is dynamic or mechanical modification. An air mass will go on to have a very high potential to become unstable as it goes on to pass over a warm water body, and particularly when this air mass is going to be warm in nature. Second is dynamic changes. Dynamic changes are also called as mechanical changes. Dynamic or mechanical changes involve mixing or pressure changes associated with the actual movement of air masses, either by turbulence, high-level convergence, and divergence. Second is the large-scale lifting resulting from the forced ascent by mountain barrier or by stream convergence. The third is the sinking caused by high-level convergence or by descent of air, that is high-level convergence or by descent of air, not ascent, descent of air, in the lee of the high ground caused by pressure gradient. The fourth is lifting caused by horizontal convergence at low level. Lifting, there is two air masses going to meet and they're going to get lifted. So the lifting caused by horizontal convergence at low level. And lastly, it is advection. There are two types of modifications that the air masses undergo. A thermodynamic modification causes the air mass to become cold or warm and is represented by letters of W for warm and K, that is in German, that is K means kalt, that is for cold. While mechanical or dynamic modification causes it to become stable, that is symbolized by S, or unstable, symbolized by U. A very short tabular explanation of how the air masses do go on to affect the weather condition has been given in the subsequent table. Now this table has been by and large explained. It doesn't require any more explanation of sorts in this case. The overall concept of air mass works very well for practical purpose of explanation in mid-latitude zones, but it is more difficult to apply in equatorial regions where air mass contrasts are less marked. Apart from this, there are a number of difficulties in applying the air mass concept in real situations. The first is, air mass types differ considerably from region to region and from continent to continent. There is no universal agreement on either an internationally accepted system of air mass classification or precise specifications of a particular air mass. A continental tropical air mass in one continent will be different, another continent different. That was all about air mass. Its classification, first its formation, its characteristic, its classification, the weather phenomena that it goes on to lead to formation of, and the appraisal of the concept of air masses.